4 of Unit 5, and so we want to deal with another concept. We dealt with the chords that intersect inside the circle. Now we're going to deal with two secants. When two secants meet on the outside. Once again, you've seen this diagram before, but we were dealing with angles. When an angle is formed on the outside, remember that we would use the equation that the measure of the big arc minus the measure of the small arc divided by 2 would give us the measure of the angle. However, with this lesson, we're dealing with the length of the segments of these secants. Okay? So what relationship exists among the segments of two secants drawn from a common point outside the circle? Now, we need to fill in this information here. If two secants are drawn, and we have two secants, segment AB and segment AC, are drawn from a common point. They both meet at point A, so point A is the common point. The blank of the outside part and the whole secant. The product once again, it says of the outside. This is the part of the secant that is on the outside. So we're looking at segment 8x. And you can see that at the bottom of the sheet here. So segment 8x times what? Outside part and the whole secant. Where's the whole secant? The whole secant goes from point A to point B. So we're talking about this whole secant segment here. So to get this measure from point A to point B, we add the measure of segment 8x plus the measure of segment xb. So we look at the whole thing. Outside times whole. Equals what? The product of the outside part and the whole other secant. So we have another secant segment. So once again, we take the measure for the outside part, segment AY, and multiply that times the measure of the whole secant segment. And the whole secant segment, we will add this part, segment AY, plus the measure of segment YC. Okay? So let's try a few problems together. Now it tells you here, once again, that secant segment AB and secant segment AC both share the endpoint, point A. This is their common point. So let's move further down in the worksheet and try a few sample problems together. Starting with problem 1. For problem 1, once again, and I kind of like to write something at the bottom of my paper to remind me what I am working with, or let's go back to the top of here. Maybe you guys can write this information here. So, going back to the original figure, segment 8x represented the part that was on the outside. So it's outside times the whole thing. How do we get the whole thing here? To get the whole thing, we add outside plus inside. Let's all write this down. So the outside part times the measure of the whole secant segment. And to get the whole thing, we got to add the outside part to the inside part. And we set that equal to, once again, for the other secant segment, we take the measure for its outside part, outside, times the measure of the whole thing. How do we get the whole thing? We take the measure for this part on the outside plus the part on the inside. You need to remember to add. Okay? We don't multiply, we add. But once we get these things set up, this is a product here, this is a product here. So let's try a few practice problems. For problem 1, alright, so you see this. Alright, so I like to begin with the one that has a variable involved. So we want to take into consideration the measure for the part outside. That is 4 times the measure of the whole thing. To get the measure of this whole secant segment, I want to add 4 plus x. But I like to put the variable in front. 4 plus x is the same as x plus 4. And set that product equal to, go to the second secant segment. For this measure, we take the measure for the outside, 2, times the measure of the whole thing. So we get the measure of the whole thing, we add outside 2 plus inside 8. We have our equation set up, so all we need to do is simplify it. Alright, so let's distribute on the left side. 4 times x, 4x, plus 4 times 4. and set that equal to, and you know what, I'll just put all of this in my calculator at one time. Let's reduce it all. So 2, open parentheses, 2 plus 8, and most of you can do this in your head, I understand, and that gives us 20. Now we want to move this into the side with this like term, so we want to undo this by subtracting 16, and that leaves 4 times x equal to 4, and if we divide each side by 4, we find that x is 1. And then of course you can go back to the original equation, plug in 1 for x, and check to see that you get the answer make sense, okay? Let's look at problem 2. Same concept. Once again, we have 2 secant segments that have a common endpoint, okay? So we want to solve for x. Since we're dealing with the measure of segments, we want to begin with the segment that has the variable involved. First of all, we begin with the 14 because it is on the outside. So 14 times the measure of the whole secant segment. So we add x for the inside part plus 14 for the outside. And set that product equal to, go to the second secant segment. Begin with the part on the outside. 12 times the measure of the whole thing. To get that measure, we add the outside. It doesn't matter which one we begin with. Inside, 25 plus outside, 12. All right, let's follow the process we used earlier. Let's find the product for the first expression. 14 times x plus, and then 14 times 14 gives a product of 196. And set that equal to, and you know the deal, just plug all this in at one time as you have it written on your paper. And that gives us about 444. Now let's isolate x by moving to 196. And that leaves 14 x's is equal to. And I need all of you working with me, okay? Not just copying, but plugging this into your calculators. Last, we're to divide each side by 14. And you don't always get really pretty numbers. We may get decimals, we may get fractions, that's okay. So divided by 14. All right, so we get a decimal value. Okay, the exact measure is 124 over 7. Let me make sure you're getting all this. Okay, which is approximately, and we want to press the SC key to get the decimal value, and this is about 17.71 hundredths. Okay, and that makes sense. So, I want to pause for a moment and let you guys try number 3. For problem 3, let's set it up. Once again, I always remember outside times whole equal outside times whole. So the outside part, and it doesn't matter. I'll just go ahead and begin on the left side. For the outside, we have 5 times the measure of the whole thing. So we add outside plus inside. Doesn't matter which one you begin with. And set that product equal to, for the other secant segment, we begin with the outside, 6. Times the measure of the whole thing, we combine x plus 6. And now let's get the final result. First, I want to place all of this in my calculator as I have it written on my paper. And I get 100. And then I want to distribute on the right side. Let's move the 36 to the side with the 100. Divide each side by 6, and we get, okay, as an exact measure, we get 32 over 3. And if we change to a decimal, we may have to put the approximate sign. So press your SD key. It's approximately 10 point, let's say 67 hundredths. There we go. Okay, so let's turn to the back, but guess what? On the back, we have a new concept to learn as well. So today we're dealing with two concepts. All right, on the front we dealt with two secants. On the back, we're dealing with a tangent and a secant. Here we're dealing, and when you have a tangent, guys, you may end up, when you form your equation, you may be dealing with quadratics. But we all know how to solve quadratics now. If we have a quadratic equation, we need to write it in standard form, and then we plug our A, B, and C values to the quadratic equation, quadratic form, excuse me. So now, here's the second essential question. What relationship exists? Because, why do we use the term relationship? Based on relationship, we form equations. So what relationship exists among the segments of a secant and a tangent, drawn from a common point, in this case point A, outside the circle? All right, so let's complete this. When a secant and a tangent are drawn from a common point, the blank of the tangent, the square of the tangent equals the product, like we've been doing, equals the product of the outside part and the whole. Outside times whole, secant. Alright, so looking at this here, we see that segment AB is a tangent. We take the measure of the tangent and we square it. So we do get a product. Alright, and we set that equal to, going to the secant segment, we take the part on the outside, segment AD, and multiply that measure times the measure of the whole secant segment from point A to point C. To get this measure, we add the outside part plus the inside. So we get a segment AC. All right, let's try a few practice problems. And once I finish with these three, you guys will receive a worksheet that you need to work on in class. If you do not finish the worksheet in class, you take it home and you can complete it. So you can keep all these concepts in mind. All right, so let's look at number one. And I think I want to go a little quicker than I've been doing. So, I like to begin with the tangent. But what is the formula once again? You take the measure for the tangent, and you square it, and you set that product equal to the measure of the outside part of the secant times the measure of the whole thing. To get the whole thing, we add outside plus inside. When you go home and write this over and over again and practice writing this, then you remember it better. Okay? So let's begin with problem one. This is the tangent. You want to take that tangent measure and square it. And you set that equal to, for the secant segment, we begin with the outside, and multiply that times the measure of the whole thing. To get the whole thing, I add outside plus inside. Alright, so x squared is equal to, if I put all of this in my calculator, let's all do it at the same time, that gives me 64. Then I want to take the square root of both sides. Now, once again, when you find the square root of a number, it is equal to the positive negative of that number. But when you think about this, for the measure of this segment, can it be negative 8 units? That's not possible. So it can be 8 units. All right? And that's the answer. So the negative would not always work. What about problem 2? Once again, you take the tangent and square it, and set that equal to the product, equal to the product for the secant. For the secant, outside, which is 9, times the measure of the whole thing. And notice I always put parentheses, because for the whole thing, I'll always have to add two measures together. In this case, x plus 9. Alright, so we know 10 squared is 100. And we want to distribute on the right side of the equation. That gives us 9 times x plus 81. Subtract 81. I know it's simple, but I can't do it in my head. So 100 minus 81. So we know we will not get a pretty answer because 19 is not a product of 9. So 19 divided by 9 gives us 19 over 9. So x is equal to 19 over 9, which is approximately